Hi viewers, welcome to this video on mathematics, and there is a question here that reads: a 3-digit number is such that twice the 100 digits is more than the 10th digit by 2. So the unit digit is thrice the 100th digit. So when the digits are reversed, the number is increased by 594. So find the number. Okay, so when we read, we comprehend that 100 digits is twice the 100 digits, that is more than the 10th digit by 2. So we got to assume that the 3-digit number is of the form, let's say this is the original number, so this is 100x plus 10y plus some number z, which is the unit digit, and we are told that the twice the 100 digit, so this is the 100 digit, so we have twice the 100 digit is more than the 10th digit by 2. So if you subtract 2, then this will be equal to the 10th digit, and that will be equation number 1, right? Okay, so the unit digit is thrice the 100 digit. Okay, so that's another piece of information. The unit digit, which is z, is thrice the 100 digits, so that is that z is equals to thrice x. Okay, that's okay. Then when the digits are reversed, the number is increased by 594. So this being the original number, so this is original number, original digit. So when you reverse, you will have technically y won't change the position, but z and x will interchange. So we'll have 100z plus 10y plus x. So this is now the reversed format of the digit. Okay, so the most unique thing about thing is y is invariant position wise, so this will help us to solve this one very easily. Okay, so it's like we have this reversed digit, subtract original number, you have 594. So we can write that in the equation format. So we have 100z plus 10y plus x minus the whole component, 100x plus 10y plus z, that is equals to 594. So we know that the like terms have to pair up. So 100z and 1z here, but of course we have to subtract. That gives us 99z, and then we have 10y, subtract 10y, that will disappear. So we have minus 99, this x and some 100x here subtracted, we have negative 99x, which is equal to 594. All right, that makes sense, and a lot of it for this case. So with that, so this is another equation. I'll denote it as equation number 3. So we can solve these three equations which are forming system of equations and solve them simultaneously. So let's do something here. All right, so you do elimination. So let's do 2x minus 2 equals to y, but of course where we have x, we can substitute where we have, okay, so let's do this. Okay, the simplest one, it will be, we express this z here, right? So we have z here, we can write it in form of x, right? So we have 99, z will be 3x, that makes sense, minus 99, x doesn't change, so we have equals to 594. That makes sense, right? So it's good when you see there is a 3 here, and this number is also divisible by 3. This is also divisible by 3, because if you add the sum of this and that will give you 9. So that's okay, but technically let's do this. We can multiply that. So we have 99 times 3, that gives me 27, carry 2, so this is 27, 297, and then that is x. Okay, so we want to subtract 99x from there so that the answer can be 594. Okay, so we know that if we were to take 297x minus 99, we are going to have the following. So we have 297x minus 99x. So we go to subtract 1 from here, we cross that, we have 8. This will be 17, that will be 8. And then 8 can subtract 9, so we subtract 1 from here, we have a 1. So this becomes 18 less 9, that's 9, and then 1. So we have 198x will be equal to 594, right? That makes sense. So we have to determine the value of x here, which technically will be equal to 594 divided by 198. Okay, so when you divide that, it will be something like a 3. Okay, so x will be 3. That's very easy to do. So x equals to 3. Now we can go back to where we have z equals to 3x and technically determine that. So z equals to 3x, but now the value of x is known, is 3, so we can determine z, and this is going to be equal to 9. Okay, that checks. So we got to use this equation here and determine the value of y. So it's very easy, because we're going to say 2 times 3 minus 2, the answer is y. So that means 6 minus 2, which is 4, that is equals to y. So basically y is equals to 4. So the original number, remember, has the following form. So we have 100x plus 10y plus z. Okay, so this becomes 100, substitute x, which is 3, so we have 3, plus 10 y, but y is 4, and now z, which is 9. So remember, it's like 9 times 1, because ones. Okay, so this becomes 300 plus 40 plus 9. You can say this one loudly. This is 349. All right, so let's do some cross check examination here, because now the original, this is the answer to our question, but if we were to reverse the digits, what would happen? Let's see. The reversed format of the digit will be, we can take 100z plus 10y plus x. So this is 100z was 9 plus 10 y was 4 plus x equals to 3. So this becomes 900 plus 40 plus 3. Say it loudly, that becomes 943. So this being the reverse form of 349, let's see what happens if you subtract. How much in excess is 943 compared to 349? If the answer turns out to be 594, then we know we have it correct. Okay, so we're going to take 943, you subtract 349. We are lucky this number doesn't change, and that is the obvious unique nature of this problem. So basically we have 13, so this gives us 4, so this becomes 3, or 1 from there, you have 8. So 13 minus 4, that's something to do with 9, and then 8 minus 3, that's 5. Seems like we have it. So the correct answer to this problem is 349, and that is quite easily done. Okay, thank you.